My theme is Botanical Garden Futures, Lessons Learned, Dreams Dreamed for the Conservation Garden. For 28 years, I served as director of the North Carolina Botanical Garden at the University of North Carolina at Chapel Hill. This talk is a very general reflection on what I learned during those 28 years. It's a very general reflection on the purpose of all botanical gardens. Here in Santa Barbara, I'm speaking to the choir. You may not learn a lot from this talk, but thank you very much for the opportunity to make this reflection. Like the Santa Barbara Botanic Garden, the North Carolina Botanical Garden has a very strong conservation focus. I want to thank the staff of the Santa Barbara Botanic Garden and the Pritzlaff family for making my visit here possible and giving me the opportunity to think about the years I served as director. I've come across the continent, but I'm still at 35 degrees north latitude. We do have different climates. The North Carolina Botanical Garden experiences high rainfall and year-round precipitation, whereas the Santa Barbara Botanic Garden experiences a summer dry period. Both the Santa Barbara Botanic Garden and the North Carolina Botanical Garden were founding members of the Center for Plant Conservation, that national network that holds the National Collection of Endangered Species as a last resort against extinction in the wild and for use in restoration and reintroduction. The Center for Plant Conservation Network is shown by the red dots in the map. And this allows me to introduce my first sub-theme, working together, working apart. We do work apart across a continent, but we work on a common goal. The talk is also based on 28 years that I served as director of the North Carolina Botanical Garden, 28 years of conversation with staff, volunteers, students, and supporters, and I have to recognize all of their contributions. Because it will be a talk focusing on conservation, I want to give a special thanks to our conservation team, which accomplishes so much of our mission. But I also want to point out that we will define the conservation garden in a way that includes all departments at the North Carolina Botanical Garden: education, conservation, the herbarium, and all who support that activity. As I developed this talk, I sent an email to a previous Pritzlaff awardee, Peter Raven. And Peter reports back, there are 425,000 species of plants, that various rankings suggest that 1/5 to 1/4 of these are now vulnerable, and with climate change that will increase to 40 and even 50% by the end of the century. We now face extinction rates that are 1,000 times the background rate, and that rate will grow to over 10,000 times within 50 years. Dr. Raven's email continues. Plants, through cultivation, seed banking, cryopreservation, and tissue culture, can be preserved in much higher numbers in a way not yet available for, say, vertebrates or insects. Through a combination of these methods and an experimental approach to them, we could save virtually all species of plants that are in existence now. We want to keep up the heat on that effort for sure. So Peter Raven has given us our prologue for this talk. Part of that challenge is represented by this slide. The graph shows that plants vastly outnumber other groups in terms of the number of listed species, but yet have the lowest funding per species of any of the groups. Here's a second sub-theme. We live at a time when biodiversity is being lost. We live at a time when human quality of life is threatened. My second sub-theme is that it's not just about getting back to zero. It's not just about preventing extinction. It's also about creating something positive. Botanical gardens are a force for creating something positive. I will use this outline for my talk. First, new lures, Botanical Garden Futures. Second, I'll tell you about southeastern plant diversity and how it's slipping through the cracks. Then I'll focus on the conservation garden and the ecological frame. I'll introduce some current challenges in conservation gardens, and finally, concluding thoughts. I take my title of this section of the talk from an article that was published in the New York Times in 2010, Botanical Gardens Look for New Lures. The article made the case that gardens were not just focusing on horticulture, but they were doing a wide variety of activities, like teaching cooking classes and healthy lifestyles, yoga, horticultural therapy, food and community gardening, children's gardens and family activities, highlighting the arts in gardens like sculpture, poetry, and music, doing conservation, whether of endangered species or by preserving and restoring nature itself. They were introducing the public to ecological issues like pollinators, and more broadly, they were talking about sustainability. We do all those things at the North Carolina Botanical Garden. I want to take those same elements and pull them together around something more important and central, a conservation mission defined to include biodiversity and people in an ecological frame. My own chancellor once complained that the university homepage was too much about azaleas and not enough about academics. It wasn't enough about classrooms and research laboratories. Now, personally, I wish those azaleas were native azaleas, of which we have many beautiful species in the southeast. But it does point out a danger. The danger is that gardens can be perceived of as the icing on the cake and not the cake itself. So let's fix that by going for deep and significant connections to social and environmental issues, as many botanical gardens are doing now. And I should point out that gardens have professors and students. They are outdoor classrooms and outdoor laboratories. So a third sub-theme will be that native plants are essential to the conservation garden, but not themselves sufficient for the larger goals. The larger goal is to include people within the same ecological frame as gardens and nature. Aldo Leopold wrote, "Who is the land? We are but no less the meanest flower that blows." Land ecology discards at the outset the fallacious notion that the wild community is one thing, the human community another. He also wrote, "All species have the right to continued existence, at least in spots." So this is a fourth and final sub-theme, the human-nature relationship through ecological sustainability. It's not people yes or no, it's how many people doing what, where are they doing it, and is that compatible with all biodiversity surviving at least in spots. My second subject is southeastern plant diversity and how it's slipping through the cracks. The gray area on this map is the range of sugar maple, and the green arrows trace my professional career, moving from Dartmouth in New Hampshire to the Missouri Botanical Garden in St. Louis to Great Smoky Mountain National Park in Tennessee and on to Chapel Hill in North Carolina. I always thought I'd live within the range of this wonderful tree. I have to include the related southern sugar maple, Acer barbatum, in the inset map to be able to make that claim today. Well, one of the things I noticed as I moved south is that the diversity of plants increased, and there's about a 10-degree latitude difference between Dartmouth and Chapel Hill, and about a 30% increase in the number of native plants. These two areas make a good comparison. New England has about the same area as the Carolinas, North and South Carolina together. They both have Atlantic coastlines and they both have high mountains. But as I made that journey, it wasn't just the increase in diversity. Something else was going on too. The plot thickens. What I was noticing was the South had many more narrowly endemic species than the North. The Venus flytrap is a good example. This is a unique and world-famous plant, Every botanical garden wants to grow this plant. I've photographed Venus flytrap in gardens in Japan and Sweden and Germany and Norway and England and South Africa and all across North America. But this red dot is the total world range of Venus flytrap, and there's nothing closely related to it anywhere else in the world. It's about an 80-mile circle around Wilmington, North Carolina. The filled circles represent counties where it's still extant, and the open circles represent counties from which it has disappeared. And this also points out that before we lose a species, we often lose geographic range, and with the loss of that geographic range, we lose genetic diversity. Venus flytrap is an endemic. It's a narrow endemic with a very small range, and that's what was catching my eye. The South was loaded with narrow endemics. There are other carnivorous plants in the Southeast. In fact, the Southeast coastal plain is one of the world's hotspots of carnivorous plants. This includes pitcher plants and sundews and butterworts and utricularias and other genera. The Venus flytrap area around Wilmington, North Carolina is one of the concentrations of terrestrial carnivorous plant diversity. Another one is the Florida Panhandle with adjacent Alabama and Mississippi. There are narrow endemics in the mountains of North Carolina too, like Shortia gallicifolia, the Oconee bell. It has its own folk song. The fairest bloom the mountain knows is not an iris or a wild rose, but the little flower of which I'll tell, known as the brave Oconee bell, even though Gillian Welch misspells Oconee. There are two subspecies, one found in a single county, the other found in just 3 counties. Very small world range for this unique species. And Torreya taxifolia, the only eastern member of this genus, confined to an area of the Panhandle of Florida and adjacent Georgia. Franklinia is also a famous narrow endemic in the South. It was found along just a single stretch of river in Georgia and has been extinct in the wild since the early 1800s. John and William Bartram from Philadelphia collected it and sent seeds to England, and it is spoken of as one of the plants saved from extinction by gardeners. There are many narrow endemics in the South, but there are also more total species. So one question is, does the increase in endemics just reflect the overall increase in diversity? The number of species and the number of endemics also would change with area. So after we correct for area and the northward decline in total species richness, is the South enriched in endemics compared to the North? With this slide, I want to convince you that the increase in endemism is not just because the total diversity increases. So let's explain this graph. The x-axis is the area on which a species list has been made, and the y-axis is the percent of the plants on that list that are in the Nature Conservancy's highest ranks for rarity, G1 to G3. The G stands for a global rank. The orange circles are places in the South. The blue circles and squares are places in the North, think New England and Canada. The green and yellow are intermediate places to North and South. What you can see from this graph is that the pattern in the South is very different from the North. At any given area, the percentage that are narrowly endemic is much higher in the South compared to the North. The percentage endemic in the South ranges from about 2% to 7% of the species list, and it increases steeply with area. The circles represent places that are along the Atlantic Ocean, and the squares represent places that are along the Mississippi, that are interior. And you can also see that the northern places have from 1 to 2% narrow endemism in their species lists, but the number does not increase as dramatically with area. Places along the Mississippi River have only 0.5 to 1% narrow endemics of their species list. And this is percentage, so it's not just a constant percentage of the total number of plants that end up on the G1 to G3 list. And to me, this slide represents the unique biodiversity signature of the South. We wanted to extend this analysis to other taxonomic groups, and we used data from the World Wildlife Fund, again from about the Mississippi to the Atlantic, and here we're using 24 terrestrial ecoregions to look at the latitudinal gradient in both diversity and endemism. These graphs show gradients from the Gulf of Mexico at 30 degrees north latitude to 80 degrees north latitude. We've also corrected all of the ecoregions to a constant area basis. On the left, the y-axis represents richness, the number of species, and we have scaled that for 0 to 1, where 1 is the maximum species diversity for each of the groups that we put on this graph. The 5 groups are vascular plants, which are green circles, amphibians, reptiles, butterflies, and land snails. On the left-hand graph, you can see that diversity declines northward, as you would expect. Some groups decline faster than others. The red triangles are reptiles, and they decline faster than the green circles, which are plants. There are a few groups that actually increase from the Gulf of Mexico to the diverse topography of the southern Appalachians, like land snails, and then decline northward. But the pattern in percent endemism by ecoregion is way different than the pattern of richness. The high numbers of endemics are found only south of about 40 degrees north latitude. Again, since this is percentage, you would expect that if it was just a reflection of richness, it would be a constant percentage. But it is qualitatively different than that constant percentage. In this slide, I've grouped the ecoregions by glacial history. The southern ecoregions didn't experience continental ice sheets. The northern ecoregions did. I've also included some aquatic ecoregions here. And you can see that endemism is much higher in the unglaciated ecoregions, where it ranges from 7% of reptiles and amphibians to 59% of crayfish, than it is in the glaciated regions, where it ranges from 0 to 1.6% of the species list. This graph tells us another story about biodiversity patterns in the South. It's a slide about beta diversity, or the rate of change through space. The x-axis is distance, and that's the distance apart of any 2 species lists in the database. The y-axis is the overlap in those species lists, in other words, the similarity of the places. And the graph generally shows that if you look at the similarity between any 2 places, it generally decreases as the distance between those places increases. Again, the blue circles are the north, the orange circles are the south. And what you can see is that at any given distance, the southern lists are less similar than the northern lists are at that same distance. And the similarity decreases faster in the south than in the north. So there's a lot of geographic differentiation in the south. Another way of thinking about it is the species list of Minnesota and Maine are more similar to each other than the species list of Georgia and Louisiana. Much of my field research has been in the southern Appalachians, and this geographic differentiation shows up there, and it also shows up particularly in the rare species. The red star is Asheville, North Carolina, and the blue diagonal line to the right is the front edge of the Blue Ridge. And these numbers are showing us the percentage of the regional rare plants that are found east of Asheville, 16%, north of Asheville, 27%, west of Asheville 28%, south of Asheville 28%. The point I want to make by this is that the rare plants are not occurring across the whole region, and some of them are confined to particular areas even within the southern Appalachians. Salamanders also show this geographic differentiation where we have narrow endemic species that have separate and small ranges within the southern Appalachians. And these ranges are not explained by environmental differences across this region. There are some hot spots of narrow endemics in the southern Appalachians, but the point is that these endemics can also be very spatially dispersed. The High Peak region of North Carolina and Tennessee is that area of the southern Appalachians in which at least some of the mountains surpass 5,000 feet of elevation. And we're going to compare the flora of Great Smoky Mountain National Park, which is 5% of that region by area, to the flora of that region as a whole. And so the y-axis is percent, the percent of the regional flora that is within the national park. As you can see, 95% of the species of plants designated as common in the region are found within the national park. And it's, it makes sense. It's hard to imagine taking an area as big as the Smokies and putting it down anywhere inside that region and not getting a common plant like red maple. The park has 70% of the regional native plants. It has 55% of those designated as occasional and infrequent. And it has only 18% of those plants in the region that are designated as rare. If we use the Nature Conservancy ranks, we see the same pattern. The park has 49% of the regional G3 species, 32% of the regional G2 species, and 23% of the regional G1 species. The rarer the species, the less percentage of those in the regional flora that are found within the national park. And that suggests that we need a network of conservation areas across the southern Appalachians to capture the variety that's present here. It could be just evolutionary history, it could be geological differences, it could be other environmental differences. Yet, at the same time, the Smokies are barely large enough for mountain lions and wolves, should they ever be reintroduced. And the area is a significant place for black bears and elk in this region. Conservation has two goals. One goal is to represent all of biodiversity. And that suggests we'll always need a network of conservation areas spread across a region. And that's what we need in the southern Appalachians, since the national park doesn't include all of the rare species of the region. But also we need some places to be large for ecological integrity in order to have species like mountain lions and wolves that require large areas. The fact that these narrow endemics don't all occur in the same small area, that they are showing this pattern of dispersion in the south through space, also means there's a danger that these species will literally fall in the gaps between conservation areas. The eastern U.S., which has a long history of settlement and a long history of private ownership, has much less conservation land set aside than the western U.S., as shown in this map. So literally, there are narrow endemics that are falling in between these conservation areas. This also shows the importance of conservation programs in botanical gardens, because there are narrow endemics that we can put into seed banks. There are narrow endemics that we can work on in terms of local conservation projects and reintroduction and restoration. The high numbers of narrow endemics means that we're also still discovering species new to science in the south. The hill cane, the May white azalea, the sandhills lily shown in the picture, and there's been about 80 species new to science described from the Carolinas in the last several decades, over 200 described for the southeast as a whole. Now we will focus on the conservation garden and the ecological frame. A garden is an ecosystem. No zoo is without plants, and some call themselves zoological gardens. No garden is without animals. One ecologist argued that gardens should be called insectariums because they have 5 times as many insect species for each plant species that they display. Native plants present an opportunity to get these relationships among species right. Native is often used as a shorthand for much broader goals. Here is a truism that I think you all appreciate. We should look at a plant, whether in gardens or in nature, not in isolation, but surrounded by its ecological context, its friends and enemies. Gardens are ecosystems. No zoo is without plants, and some call themselves zoological gardens. No garden is without animals. One ecologist argued that gardens should be called insectariums because they have 5 times as many insect species as they do plant species. Native plants present an opportunity for getting the relationships among species correct. One of the subthemes of my talk is that native and native plant gardens, those phrases are a shorthand for much broader goals. One of my favorite places that uses an ecological frame is the Arizona Sonora Desert Museum in Tucson. It presents the plants and animals, the geology, the various cultural groups that have lived in this landscape, and the geologic and human history of the Sonoran Desert. We might call this an ecosphere or biopark and not a botanical garden, but they do gardening there, and the kind of gardening we might call ecological or ecosystem gardening. They also protect remnant natural areas of the desert. Gardens often protect natural areas, and they are, in general, a transition from human-dominated places to nature-dominated places. That gives botanical gardens a great opportunity to teach across that entire spectrum. One question we could ask about the ecological frame is, does this broadening from garden to that ecological frame lessen the importance of plants? I'll answer no, and I'll use a quote from our founding director, Richie Bell. "Plants aren't important," he once said, "unless you like to breathe, eat, take medicine, wear clothes, or build houses." Plants are the energetic foundation of almost all life and almost all ecosystems, and they have a central place in the ecological frame. There is another reason that the ecological frame is important. People are part of ecosystems and should be included in the ecological frame. Lack of ecological literacy is a problem in today's world. Ecological literacy is based on science and knowledge and experience, the beauty, enjoyment, respite, and inspiration we take from plants, gardens, and nature. Botanical gardens are perfectly positioned to do both of these elements. The third section of my talk, the conservation garden. I arrived in Chapel Hill in 1986, and we soon began to discuss the conservation mission. Based on those discussions, I published an article in the Public Garden in 1996 titled "In Search of the Conservation Garden." I'll define the conservation garden in 2 ways. First, the bottom-up way, I will define the conservation garden through 8 programs of the North Carolina Botanical Garden. And second, the top-down way, I'll use Bill McDonough's Hanover principles to define the conservation garden. The Conservation Garden 1, Sustainable Gardening. This is bringing the best environmental practices into the world of gardening. The Conservation Garden 2, Conservation through Propagation. This predates my arrival at the garden, but the garden had always promoted the use of native plants. The danger is that using native plants in gardens will result in damage to wild populations through wild collecting. And so the staff developed a policy to promote to the public that plants used in gardens should be gotten from propagated sources, not from wild collection. The Conservation Garden 3, natural areas. This was the idea that remnants of nature on botanical garden lands are not blank spots to be considered for future development, but can have value as natural areas, that we should conserve those natural areas and restore them to their best condition. The Conservation Garden 4, nature's context. This is gardening with ecological relationships in mind, like pollinators and seed dispersers. Also, native plants and those ecological relationships help us develop a sense of place. Nature presents an ever-changing quilt of biodiversity, and each place has its own unique combination of those elements. The 5th Conservation Garden Program, invasive plants. We worked on this issue in the 1990s. We wrote up a statement of principles that I titled the Chapel Hill Thesis. I published that statement of principles in the newsletter of the American Public Garden Association, then known as AABGA, under the title The Chapel Hill Challenge for Halting Invasives, the Chapel Hill Thesis, a challenge to botanical gardens and horticultural institutions. I also published it in the Botanical Gardens Conservation International newsletter. Calling it a thesis gave me the inspiration, like Martin Luther, of nailing it up, and I nailed it to an invasive paulownia tree on our own nature trails. The staff has since, of course, removed that tree. I then began working on the invasives issue with Sarah Reichert of the University of Washington. She and I put together a symposium for the annual meeting of the American Public Garden Association, and the papers from that symposium were published in a special supplement to the Public Garden. My article was called A Bill Falls Due, Botanical Gardens and the Exotic Species Problem. Sarah and I then worked with Peter and Pat Raven, Catherine Kennedy, Peggy Alwell, and representatives from the Garden Clubs of America, the horticulture industry, and government to put together an international meeting in St. Louis on this topic. What emerged from that meeting was the St. Louis Codes of Conduct. That's a statement that can be adopted voluntarily by individuals or institutions that will lessen the role of gardening and horticulture in the spread of invasive species. The problem is not just that gardens import species that may become invasive in surrounding landscapes. It's also that they distribute species, sometimes to a wide geographic area. Botanical garden seed lists, even before the internet, often went out globally. And with the internet, that interchange of seeds is all the more easy. So we enacted a new policy, the new conservation policy. We will distribute seeds and plants within a 12-state region of the Southeast, from the Mississippi River to the Atlantic Ocean, and from the Gulf of Mexico north to Kentucky, West Virginia, Maryland, and Delaware. We use that geographic zone as a kind of shorthand for avoiding the risk that the seeds that we sent out would cause problems in new landscapes. Our goal is to reduce the risk of new exotic plant invasions that impact our natural areas, and to encourage the use and appreciation of native plant seeds from local sources. Our hope is that our revised seed distribution policy will result in an increased appreciation of your region's unique local flora and nurture the growth of all regional botanical and horticultural institutions throughout the country. No one garden should supply seeds to a large geographic area. The Conservation Garden 6, Seed Banks. The North Carolina Botanical Garden, like Santa Barbara, was an early member of the Center for Plant Conservation, the organization that holds the National Collection of Endangered Species as germplasm samples as a last resort against extinction in the wild and for use in reintroduction and restoration. We've also worked with the Millennium Seed Bank Project at Kew Gardens and we've worked with Seeds of Success of the Bureau of Land Management. And in the lower left, you can see Gary Kaufman from the Forest Service picking up a load of seeds to be used in a restoration project in the North Carolina mountains. We hold 64 species that are ranked G1, G2, and G3 by the Nature Conservancy. 31 of those are federally listed, 8 have been used in reintroduction projects, and 42 are in our seed bank as well as in the National Collection of the Center for Plant Conservation. Our seed banking work has put us in collaboration with many land managers of the federal government, the state government, and private conservation groups. This is an example of a project we did at Fort Bragg, a 4-year ecological restoration project that included restoring populations of endangered species. The Conservation Garden 7 is research and information, and I use as my example the UNC Herbarium, a department of the garden. It's the largest collection of plant specimens in the Southeast, and so it's vital to understanding the identity and distribution of plants in our region. We partner with other institutions, with the National Science Foundation, to put data on the web, to create databases, and of course we do lots of public service based at the herbarium. And last, the Conservation Garden 8, education and experience, providing information and providing positive experiences with plants and nature. A summary of the 8 programs of the Conservation Garden at the North Carolina Botanical Garden. Garden sustainably, practice conservation through propagation, protect and restore natural areas, garden in nature's context, eliminate invasive species from gardens and natural areas, develop seed banks as a last resort against extinction in the wild and for restoration, carry out research and provide information, provide education and experience for a wide audience. Bill McDonough came to the North Carolina Botanical Garden in the late 1990s and gave a speech that changed all our lives. It was based on his book, The Hanover Principles, Designed for Sustainability. And he said that all human endeavors should be discussed under 5 headings. Earth for recycled, non-toxic, sustainably produced materials. Air for air quality indoors and out. Fire for energy use and renewable sources of energy. Water, the lifeblood of both gardens and human life. And spirit, the spirit of all living things, of the staff, the volunteers, the visitors, but also the birds, the butterflies, the plants, the fungi, the nematodes, the insects. This became our second way of defining the conservation garden: earth, air, fire, water, and spirit. Those 5 words also became a kind of mantra at the garden, celebrating life's forces. Bill McDonough also said that we should go beyond sustainability. He wrote that we should judge a building not just by its energy use, but by the number of birds you can hear singing from its door. So I had some of my conservation biology students assess the bird diversity before the construction of our education center and then after. And we lost not one bird species. We passed Bill McDonough's test. Bill McDonough also said, let's talk about sustainability in a new way. If you think about sustainability, is it really that exciting? What if I asked you, how's your relationship with your husband, and you say sustainable? I would almost feel as if I had to say I'm sorry to hear that. So shouldn't we really be looking for something that is actually fecund, that's full of blood and vigor and excitement? Sustainability is a broad label, and so we can ask the question, is it too broad for plant diversity? I always feel like I have to remind my own sustainability office on campus that biodiversity, the protection of natural areas, and campus horticulture are sustainability issues. And what about that word green anyway? Permit me to go on a rant. Gardens had the word green first. Plants and photosynthesis are green, and they take carbon out of the atmosphere, so they're doubly green. I have a guilty confession. Yes, we built a green building at the North Carolina Botanical Garden, and it even has not one, but 2 green elevators. One day I was giving a hard hat tour of the building when it was under construction, and I found myself standing at one of the green elevators, and I was beginning to explain that it was green, despite the fact there was no green color anywhere. And I came up with this proclamation, taking back the word green. As of 2008, anytime someone uses the word green for something that isn't a plant, that person is hereby fined 5 cents. In this part of the talk, I'll briefly review 4 challenges for conservation gardens. Those challenges are incorporating the issue of a sustainable food supply into gardens that focus on native plants and conservation issues. Second, collections policy, defining the word native in times of habitat fragmentation and climate change. Third, determining appropriate gene pools, the risk of outbreeding depression, and the designation of seed sources for restoration. And finally, using assisted migration. A sustainable food supply. It can seem hard to connect to this issue to the local food and community garden movements in gardens that focus on native plants, or to teach about global food issues and agricultural practices. There are ways in, however. Shared pollinators and pest control, those ecosystem services that are supplied by the native landscapes that surround farms. And that was the subject of a speech by last year's Pritzlaff awardee, Claire Kremen. In addition, Native Americans had many uses of the native plant diversity of their landscapes. The conservation garden idea does allow us to include community gardens more directly. And this is the Carolina Campus Community Garden of the North Carolina Botanical Garden. Almost no crop plants are invasive in surrounding landscapes, and gardening activities can be done in a sustainable way. My second issue in conservation gardens is the definition of nativeness. In a changing world, native, in the context of collections policies for botanical gardens, must be defined in a dynamic and ecological sense. We should avoid an inordinate defense of historical distribution, but recognize that continuity with the past has value. The definition of native is never arbitrary or unconstrained. It's contiguous with today's distribution, and that's a scientifically tractable issue. Here is a map from the work of Kay Havens at the Chicago Botanic Garden. She's showing the predicted future trajectories of rare plants with climate change. As you can see, our eastern rare plants are predicted to move north and east. This is the kind of analysis we will need in order to define collections policies in the future and to determine appropriate seed sources for restoration. In this table, Kay is giving us guidelines to think about seed sourcing with more conservative local seed sourcing on the left and more relaxed longer distance seed sourcing on the right. And she's using species characteristics and habitat characteristics to suggest when we are in one of those categories or the other. An issue that is related to our collections policies and definition of native and appropriate seed sources for restoration is the risk of outbreeding depression. I won't go through this entire decision tree, but here's the summary. Francom suggests that outbreeding problems occur when there are fixed chromosomal differences between the taxa that may hybridize, when there's been little gene flow for 500 years and populations have been separated for 20 or more generations, and when those populations are in very different environments. My fourth issue is, when does assisted migration make sense? I won't go through this decision tree either, but here's a summary. The paper suggests assisted migration makes sense when there's a high risk of decline, when the species can't move on its own, when it's impossible to improve corridors, and when appropriate habitat exists elsewhere. Research is required for questions about nativeness, seed sources, outbreeding depression, and assisted migration. The answers to these questions often begin, "It depends," and that can be frustrating, but it does depend. It depends on context. For example, on species characteristics, evolutionary history, and the degree and immediacy of threat. The key is to understand the factors on which the answers depend. Conservation science creates a toolbox rather than a single answer that applies in all cases. And often research is limiting, and we operate under rules of thumb. If so, we have to monitor and learn from our experiences the best way to go. We have to adopt adaptive management. Of course, science informs our work, but our work in botanical gardens can also generate science. Learning how to grow these plants is an important contribution. And further, plant taxonomy is itself endangered as it gets lost from modern biology departments at universities. It can find a new home and be protected in botanical gardens. This report on the plant conservation strategy says that we've made no recent progress on the number of trained people working with appropriate facilities sufficient to national needs to achieve the targets of this strategy. And the report specifically says that the training and capacity building can be supported by and occur in botanical gardens. So I've come to concluding thoughts. I will return to the four sub-themes of this talk as conclusions. These conclusions won't be very earth-shaking or surprising. Working together, working apart, the conservation challenge requires networks of activities spatially distributed throughout the globe. And it's not just getting back to zero, but creating something positive. Gardens, with their diversity of plants, their richness of color, their seasonal changes, and the relationship between plants and animals, they're great places to develop that positive relationship. Native plants are essential, but not themselves sufficient for the larger goals, but they are nested within those goals. And finally, the human-nature relationship through ecological sustainability can be a central theme in botanical gardens. My last thoughts. Conservation is like a baton. We can't solve all problems for all time. We won't see a final solution, but we can pass on the world in the best possible condition that we can achieve during our lifetimes and our careers. The simplest definition of best is to pass on as much genetic and species diversity as we can. It's the raw material of resilience and adaptation. And to create and improve ecological literacy among all people. We need to reach as many people as we can to increase that ecological literacy and to support a positive relationship between people and the natural world. For the sake of argument, I'll take an optimistic view. Humanity will be okay. We just need 500 years to sort it all out. And right now, we just need to squeeze the maximum amount of species diversity, genetic diversity, and wild nature through the narrow neck of the hourglass we face over the next period of time. We will have to create and improve ecological literacy in our own species to do that. So thank you for your attention and for allowing me to reflect on 28 years as director of a conservation garden.